All right, in this video, we're going to talk about L'Hopital's rule and the indeterminate form of infinity over infinity. So again, back at the beginning of the semester, when we are doing limits at infinity, so I'm walking forever, we would look to see if the graph had a horizontal asymptote. So this graph has a horizontal asymptote at the x-axis. So what's happening is as I plug in infinity, the bottom is dominating, so it's going to slam the whole thing overall to 0. Okay, that is still true, and you can still solve these limits that way. However, it turns out that L'Hopital's rule works for the infinity over infinity case. So what that means is that when I plug in infinity, I get infinity plus 1 is infinity. I got 2 times infinity squared plus 7, that's also infinity. Okay, so what you want to do is you want to verify I have infinity over infinity. If I get that, I'm going to do L'Hopital's rule. So I'm going to write that LH so that we can let anybody know who's looking at our work what we did. And we're going to just take the derivative of x plus 1, which is 1. We're going to take the derivative of 2x squared plus 7, which is 4x. And now I'm going to plug in infinity. Okay, so if I plug in infinity, I'm going to get 1 over a huge number. 1 over a huge number is 0. That's the same answer I got earlier talking about the horizontal asymptote. So what this does is it gives you options. If you like the previous way of doing these problems, which was using dominance and horizontal asymptotes, you can go for it. Otherwise, if you like L'Hopital's rule, you do have to verify you have our form of infinity over infinity, and then you can take the derivative of the top, derivative of the bottom, and go. Okay, now, I will warn you, sometimes these problems get messy because you have to take it a couple times. So here's what I mean. So let's say I had the limit as x goes to infinity of e to the 2x over x squared plus 4. Okay. All right, now, again, our answer, you could actually figure out this answer ahead of time using just which function do you think grows faster? Do you think the top grows faster, so that's going to blow up, or do you think the bottom grows faster, so it's going to slam it to 0? The top grows faster, so our overall answer is going to be infinity. However, if you want to use L'Hopital's rule, this is going to have, so the very first thing you have to do is you have to verify you have infinity over infinity. So if I plug in infinity, I get e to the infinity. That's definitely infinity. And I get infinity squared plus 4. That is also definitely a huge number. Okay, check, it fits our form. So what I'm going to do now is I'm going to take the derivative of the top and the derivative of the bottom, and I'm going to write LH. So anybody looking at my work knows what I did. Okay, the derivative of e to the 2x is 2e to the 2x. The derivative of x squared plus 4, 2x. All right. All right, we can definitely reduce the 2's. Great. But if I plug in infinity again, what you're going to notice is I'm going to get e to the infinity, which is infinity, over infinity. So we get to use it again. So L'Hopital's rule, sometimes you could use it 2-3 times in a problem. You just have to make sure that it still applies. So here I go for round 2. Okay. When I take the derivative of e to the 2x, I'm going to get 2e to the 2x. When I take the derivative of x, I get 1. All right. Now, when I plug in infinity, I get 2e to the infinity. That is definitely infinity. Divided by 1. That is just infinity. So my instincts that the top was dominating the original problem hold true. So this is what this is saying. This is saying that the e is dominating, causing the whole fraction to blow up. That x squared plus 4 in the denominator wasn't taken enough away. All right. So there's the infinity over infinity case.